New research on dark energy, which is that mysterious force that makes up most of the universe, 70% in fact. Well, this new study suggests it may be weakening. Data from the Dark Energy Spectroscopic Instrument, or DESI, shows the force was stronger in the early universe, but has diminished over time. Now, if this trend continues, this is what matters to you, it could cause the universe to eventually collapse in on itself in a big crunch, rather than expanding forever. However, more studies are needed to confirm this theory. To help us understand what this really means, let's bring in Mustafa Ishak-Bushaki. He's the co-chair of the DESI Working Group and an astrophysics professor at the University of Texas at Dallas. Professor, wow, help us understand what this new data is and why maybe some of us should be concerned.
Morning. Yes, this data is telling us information about the acceleration of the expansion of the universe. What this data is telling us is the properties of this dark energy causing the cosmic acceleration. So the fact that the universe is expanding is something we know for the last 100 years. No surprise there. It comes from the theory of relativity, general relativity of Einstein. That's not surprise. What is a surprise is something that happened in 1998, is to find out that the universe expansion is accelerating, which led to a Nobel Prize in 2011 in physics. But for 25 years, we were in the dark. We did not know what exactly is causing this acceleration. We thought for 25 years that it is a cosmological constant, like this energy is constant. Now, what we found with DESI is that this energy is not constant, and this energy is changing with time. In fact, it's changing and it's weakening. So now it is weakening, but which means that the acceleration will diminish and diminish. If it continues, then the acceleration will go away.
That is absolutely fascinating. And just so folks understand, dark energy, dark matter is the stuff in between the planets, in between the stars that we're all kind of suspended in the universe. So if what you're saying is, we all know about the Big Bang, maybe that the expansion has slowed and now it might reverse. Do you have a timeline for when this so-called big crunch could happen?
Yeah, sure. But before, let me just be a little bit more specific.
Sure.
So we don't see that the universe is slowing down. Not yet. No, we don't see that. What we see, it's accelerating less. It's still in an acceleration. It's accelerating less because the energy that is pushing it to accelerate is diminishing.
Right. Yes. And we should note that dark energy and dark matter are completely different things. So help us understand what the next step is in your research. It sounds very important.
Sure. We should not worry about this because this is going to happen like in billions of years. If it is to happen, it's only one possibility. It's not that it's necessarily we're going to stop and crunch. It's not, that's not necessary. One of the solutions is that we may stop in some theories, we may stop expanding and recollapse, but that is not the only solution. It may keep expanding at a constant rate. So it's only a solution. What is next is that now that we have the numbers, we want to find out what is it exactly. That's the next step. And also, we are building more significance to the result. We're at 99.998. We want to go even farther for further evidence.
It's so fascinating to listen to your work. I encourage folks to look into this. Professor Mustafa Ishak-Bushaki, we appreciate you joining us from Dallas this morning.